All right. Similar thing. This one's piecewise though, so it could have a jump. The white note packet says, make sure you get this memorized, the jumps in a piecewise will occur at the transitions. The x-coordinates where you change from one formula to another. So for this problem, if there's going to be a jump, it will be at x equal 4. It cannot occur anywhere else. However, I have not yet confirmed that to be true. So I'm just writing down x equal 4 because I know that's the only place it could occur. I need to go check. So again, from the white notes, I remember this. A jump occurs when the left-hand limit and the right-hand limits are different. So back to Timmy's question, another point for Timmy. There's two more. I'm going to use limit notation this time because I want to communicate to the grader what I'm thinking. So I'm thinking, okay, I need to go find the limit as x approaches 4 from the left. And here's my formula. This is review, so everyone in the room can get extra credit for this. Raise your hand, talk to each other if you need to. What do I write here? What is the limit of this function as x approaches 4 from the left? Looking for hand. Show me your hand. This is review. What is the limit? Charlie got sleepy. It's all right. Let him sleep. It's just good. Just let him sleep. You can watch the videos. When you're tired, you're tired. You just gotta have some sleep. Emily, please.
X squared minus 10.
So I look up here and I say, finding a limit means find a y coordinate when the x is slightly less than 4. So Emily correctly went here and said, x is less than 4, so I've got to use this formula. I do need to plug that in, though. So I think, okay, close to 4 squared is going to be close to 16. Minus 10, this should be exactly 6. Please raise your hand if you knew that before I wrote it. 2 points, okay, 3 for Emily. Question. We need to talk about it more. Charlie's back. All right, welcome back. It's all good. I know exactly how you feel. When you get sleepy, it's like you just can't help it. So just if you sleep, it's good. You have to fall asleep for just a few minutes and your brain resets and you're good. So good work. I've said your name like 4 times, marked down 4 points. So. We need to find the limit as x approaches 4 from the right. Please raise your hand if you can tell me what I should write. Go. Show your hands. Don't ever take points if you're not raising your hand. It's the way I determine how we're doing as a class. So let's go, Emma Reynolds.
Would it be 3x minus 2? So then, well, like that's what you would use.
Keep going, Emma. You're doing great.
Then it would be 10.
Perfect. So Emma correctly picked this formula because we are using an x-coordinate that's a little more than 4. That means the y-coordinate is going to be really, really close to 10. Hence, the limit is exactly 10. How many knew it? 2 points, 3 for Emma. Question. Sweet. You have this memorized, so now you remember. Oh yeah, left and right limits are different. There is absolutely a jump at x equal 4. Question. Please, Cameron.
So just to make sure, you're talking about just what you get from those equations, like the green and the red things. Since that's 6 and that's 10, that's the jump.
Perfect. 3 points for Cameron. Let me go back through. So look, everyone. Okay, what you're doing is exactly what everyone needs to do in this class. You're trying to figure out, why did he come into that conclusion? You're not just saying, okay, I do this, then I do this, and I have no idea why. So here's the logical sequence of thoughts. I'm trying to see if there's a jump. First one, I remember from the white packet. Jumps only occur in piecewise. This is piecewise, so maybe there's a jump. Second thing I remember, if there's going to be a jump, it occurs at a transition. Transitions are where we switch from one formula to another. That's x equal 4. So maybe there's so I look there. Now I just remember this definition. To verify whether there is or isn't a jump, check left-right limits. I did, they're different, hence jump. Perfect.
So if they were to be the same, it wouldn't be a jump?
Perfect. 3 points for Melissa. If this comes out to be 6, or the top one comes out to be 10, whatever, if they come out the same, you would come over here and say no jump. There is no jump. Please.
Wait, so if the top one was 10, but then if the middle was still 6, then there's no jump?
Listen to Stockton, 3 points. The value of the function, like look at the definition. You're doing perfect, you really are. Look at the definition. The definition says nothing about what's happening at, in our example 4, like precisely at x equal 4. It's back to the list again. All we do all year long is we just keep focusing on this list. We're not looking for what's happening precisely at 4. We're looking to see what's happening a little bit prior and a little bit after. So even though this one, as Stockton said, when x is 4, y is exactly 6. This right here has absolutely 0 to do with whether there's a jump or not. It's all about the left limit and the right limit. Perfect. Please.
So on the first one, the green one, it said x is equal to or less than 4, then it wouldn't even matter, like, when you're finding the jump.
If this said equal to, I would still need to use the top formula when I'm finding this limit.
Yeah, that's what I mean.
What?
It doesn't matter.
Well, as far as the jump, it makes no difference whatsoever. Is that what you meant, Ainsley?
Yeah.
Perfect. Yeah, whether this is less than or equal to, because all I'm concerned about are these two, as far as the jump, it doesn't matter at all.
Okay.
It will come into play if there's a removable or not, because now I have to compare it to the actual function's value. Is that what you meant?
Yeah.
3 more. Please.
So you said that it can only happen at a transition. Is a transition always an x equals 8? I just don't get that. Like you said x equals 4 is a transition.
You're okay, Allie. Let me give a couple other examples. In this piecewise function here, there are 2 x coordinate transition points. The transitions are when you switch from one formula to another. So in this example, you use this formula when you're making your list of xy pairs. You use that top formula for all x's that are less than 2. Once we switch, though, for x's between 2 and 5, we switch to a new formula. So that's what I call a transition. So this one would have a transition of x equal 2, but also x equal 5. I'm not sure I answered your question, though.
No, that makes sense.
You good? 2 more, Alex. Anybody else? Awesome. Okay, back to here. Wrong problem. That one. Okay, removable. In the last example we talked about, one way to get a removable discontinuity is to find an x coordinate where you end up with 0 divided by 0. We are not going to have that type of removable discontinuity in this problem because none of these formulas have the capability of becoming something divided by 0. They don't have a denominator other than perhaps 1. Questions? This is why I say getting the notes memorized is crucial, because you're given a problem, you just have to be able to recall that information quickly and go, okay, wait a minute, yeah, it can't be this type of removable because I don't have a 0 on the bottom. Please, Johnny.
You would figure that out by plugging 0 to the x's, right?
I just look at it and say, it's not plugging 0 in for x, it's plugging any number in for x, and trying to see if you're ever going to end up with 0 divided by 0. That makes sense.
Yeah.
So I can tell from these formulas, it doesn't matter what x I pick, the formula never becomes something over 0 because there's no bottom to the formula. as opposed to this one. 1 second, Allie. This example, there's definitely a denominator. So I can find an x that will make the bottom 0. Allie, please.
So if it's a piecewise function, then it's not going to have a removable?
Not necessarily. It's not about being piecewise, 3 points for Allie. It's about me noticing that there's no way to get a 0 over 0. Please, Claire.
On the bottom of the blue page, the notes, it says removable is at x equals a if the limit of, like, so this one, it would be the limit as x approaches 4 doesn't equal f of 4. So, and you know that the limit as x approaches 4 is D&E because for a little less than 4 is 6 and a little more than 4 is 10, so they're not the same.
Keep talking, Claire. You're doing
So
great.
then, wouldn't it be, because it says x equals a, so would it be 4? Because you're using, I don't know.
You're doing just fine. 3 points for Claire. Here's what she noticed. So putting what Allie said and what Claire said together, there are 2 ways to get a removable discontinuity in our class. One way is what we saw in this example. Come on, go back. Here, where we ended up with 0 divided by 0. Another way, and if you get 0 divided by 0, it does meet this definition that Claire was noticing. Like that still occurs. Another way is just strictly by the definition, which is what you're checking for in this piecewise function. But what Claire noticed was, come on, because the left and right limits are not the same, the overall limit is non-existent. Well, that's because we have a jump. We're not going to have a removal and a jump in a piecewise function for our class. So this one has the jump at 4. It does not have a removable. You can watch the entire video for this at home. When you work number 3, you discover the opposite. You discover that the left and right limits are the same, hence there is no jump. But you find out that the value of the function, this is what Claire was talking about, is different than the value of the limit. That's a removable. And so example 3 has the removable at x equals 3. And I can't go too much deeper into that right now just because of lack of time, but let's go, Timmy.
So on the piecewise functions, will we ever be able to get to a 0, 0? Will we be mostly just using strictly the definition?
Mostly the definition, but I have seen problems where they can make one of these formulas have a denominator.
And
then you got to worry about that.
But only if you see a denominator.
Correct.
Okay.
2 points. Please, Zach.
When we were doing the removable x equals a in the bottom right, why did we choose 4 for a?
Oh, because, good question, 3 points. So in this example, I really didn't know what x to pick. Once I factored, I could see what x's were important. In the piecewise example, because there's no way to have a denominator, I know already what x's are important. It's the transitions. And so that's why I'm working with 4. Does that answer your question?
So then if the transitions aren't always at 4?
You'd look wherever the transition is.
Oh, okay, and then
So-
you just do it again for each different
Right.
transition?
Kind of like I was saying to Ali, this one has transitions at x equal 2 and x equal 5. There's no denominators, so I'm not worried about that, but I am going to worry about what's happening at the transitions. Is that your
All right.
question?
Yeah.
3 points. Okay. Said Ali's name a whole bunch today. Keep marking them down. Okay, look at the vertical asymptote. Look hard. Look. We've already talked about a vertical asymptote occurs whenever you end up with the y-coordinate being a number divided by 0. These formulas for finding the y-coordinates don't have the possibility of ever being a number divided by 0. So I'm done. Question?
Can you say that one more time?
So I'm just looking specifically at item 8, 2 points for Claire. And I'm noticing the only way to end up with a vertical asymptote is if I have a y-coordinate that becomes a number divided by 0. These are the formulas for finding the y-coordinates. But none of those have any possibility of becoming a number over 0, so no vertical asymptote. Okay, the limits go quick. We've already done them. The limit from the left is 6. The limit from the right is 10. The overall limit is non-existent. And we already found f of 4 to equal 6. Questions? Please.
Is there any questions in this packet where there is a vertical asymptote?
Oh, for sure. Like we found one here in example number 2. And there are others. Question, Jake? 2 points? Is that your question, Jake?
Yeah.
Yeah, please.
So a piecewise function will never have vertical asymptote.
2 points for record. Everyone listen hard. Listen. A piecewise function can have a vertical asymptote if one of the formulas is such that for some x, you could get number over 0. This one doesn't. I don't know that any in this packet do, but don't think that they couldn't. They definitely could. Does that answer your question, right? Okay. Awesome. We got, oh yeah, please, Cameron.
So, just a small thing. I'm still confused with the removable discontinuity, and just like that, like it says removable is that x equals a, and over there, like can you just say that in layman's terms, or just put it simple?
Sure. This one here.
Yeah.
The way I like best is I like to use my hands. So like I like to picture that the graph is like right in front of me, but I'm doing this for you, not me. And like let's say this is x equal, so a is just some x coordinate. So just let it be 5. So here's x equal 5. Actually, we'll do 4 because that's this example. So here's x equal 4. If I'm finding the limit as x approaches 4 from the left, it's as though I'm following all the dots with my finger. And when I get over here close to 4, I find that the y-coordinate is 6. With me?
Yeah.
Then I use this hand to find all the y-coordinates here, and I find that that y-coordinate's 10. That's why I know there's a jump. Because my left-hand limit and my right-hand limit are different. With me?
Yes.
Okay. If there's not a jump, I go looking for a removable. So I always look for the jump first. If I find this to be the same as this, then I'm like, oh, no jump. Now I want to look for what's happening right in the center. Because this right here, limit as x approaches a, that's talking about left and right. And if those are the same, then I have an overall limit. F of a is talking about the middle.
Oh, so it's like doing like that thing you have up there where it's like there's 4, well like there's 4 minus or whatever you call it and 4 plus.
Uh-huh.
And if it does equal, like if they all equal the same thing, then that's
If they're all the same, it's the third box in your notes. The function's continuous.
okay. Oh, okay.
If these two are different, jump. If these two are the same, but this one's different, removable. That's what the definitions are telling you. Thanks, Matt. Good
I'm
point,
just
Kim.
confused because, like, so x equals 4 is 6. So, like, we know that at 4 it's going to be at 6. But then the 2 is a jump, so it would be different, right?
So what you'd see on a graph is we're really only looking at theoretically 3 points. We're seeing the point that's right before x equals 4. That value has a y-coordinate of 6. Then we're seeing the point right at x equals 4, also a y-coordinate of 6. Right after, the y-coordinate's 10. That's why we consider it a jump.
Okay.
I'm not sure that answered your question.
Yeah, I'm just confused why it's not a removable. If it's different than, I don't know.
Oh, just the definitions.
Oh, okay.
If the left and right limits are different, that's a jump.
So on the first homework, when we did like, is that different than what we're doing now? Or is
No,
that?
it's the same. Keep talking.
Because I'm just confused, because like when we did the first, let me see if I can get it.
You're okay.
Like, we did like the removable here, and so like f of 0 was like this. So it was like different, but that's how this is, but it's not. I don't know if I'm really making
Hold that
any
question,
sense.
man. I'll have to look at that in a second. You're good.
Okay.
Everybody look up. Hey, look.